All right, folks, it is 10:30, so I think I'll get us started. So welcome to WSPS's Safety Connection on air assessments, what they are, and MLITSD campaign compliance. My name is Madison, and my co-host is Jay Young, and I'll be introducing us a bit more shortly, but before we get started, let's go over a few housekeeping items together. First, we have a MLITSD demographics collection survey. So this is a short survey collecting demographic information on behalf of the Ministry of Labor, Immigration, Training and Skills Development. Responses are completely anonymous and no personal information is collected. Participation in the survey is optional. If you do want to participate, you can click the link here, click the link here or scan the QR code here and use the function number 230346 for access, and I believe it's also been included in the chat for you. We recommend that you use your computer audio with headphones for this safety connection, but phone conference is also available, and the phone conference details can be found in the access email you received. Your camera will remain off with your microphone muted throughout the safety connection. To submit questions and communicate, please use the meeting chat. Just a reminder, folks, that the meeting chat is public and messages are seen by all participants. We'd love to have an engaging session today, and we'll be using a few engagement features. The first one is the react or reaction feature that's found in the menu bar. So give me a thumbs up, folks, if you're able to reuse that reaction feature. Awesome. We should see some thumbs up floating. Perfect. Lots of thumbs up. Awesome. We've got it. Next, we'll be using polls. So polls will appear in the chat or pop up on the screen. Just choose an answer and click submit. And then lastly, we'll be using the meeting chat, which can be accessed through the menu bar. And you can type messages at any time. Just again, a reminder, folks, that the meeting chat is public. Microsoft Teams also has some accessibility features that might be of use for you. The first one is live captions. So if you do want to turn on live captions, access more in the menu bar. So the three dots, select language and speech, and then turn on live captions. If you want to view the safety connection in full screen mode, select view, more options, and then full screen. And both of these features can be disabled following the same instructions. If you have any technical difficulties throughout this safety connection, please just put a message in the meeting chat. WSPS's Safety Connection program has 4 main goals: to learn, share, and discover what is of value to you, our clients, and our community, to connect virtually with industry peers, to facilitate a best practice exchange, and to provide an opportunity to attend a health and safety webinar from your personal workspace. So next, I'll introduce both Jay Young and myself, and then we'll get started into some of the great content that we have for you. So my name is Maddie, or Madison Seeloff. I have a Master's of Public Health degree from the University of Toronto, and am a certified industrial hygienist with the Board for Global EHS Credentialing and a registered occupational hygienist with the Canadian Registration Board of Occupational Hygienists. I have been working as a specialized consultant since 2018 and have delivered various hygiene consulting services across Ontario, including conducting air assessments, which we'll talk about today. At WSPS, I'm a specialized consultant in occupational hygiene, providing technical support to workplaces in Central Ontario. My colleague and co-presenter, Jay Young, is a specialized consultant in occupational at WSPS, supporting workplaces in Western Ontario. She joined WSPS in 2023 and has been providing occupational hygiene consulting services such as chemical and noise exposure assessments, designated substance assessments, and program development. Prior to joining WSPS, Jay Young worked as an occupational hygienist in the nuclear industry as well as in the railway industry. She also has a Master's of Public Health degree from the University of Toronto and is a certified industrial hygienist with the Board for Global EHS Credentialing. Now, folks, I'm going to hand it off to Jay Young to take us through the first part of our safety connection.
Thank you, Maddie. So first, let's all think about why we need to put in the effort to protect our workers. The MLITSD report on their website that occupational diseases are the leading cause of worker deaths. Exposure to hazardous chemical agents in the workplace may result in the worker developing an occupational illness. So identifying, assessing, and controlling these exposures will help lower the risk of workers developing an occupational disease. And it was very shocking to me when I saw these statistics from the WSIB regarding the allowed fatality claims over the years. So what you see here in this chart is that each bar represents the fatalities by death year, and the portions that are represented in the gray are the occupational disease fatalities. So not only the total number of fatalities that occur are shocking, but also that occupational disease fatalities far outnumber the traumatic fatalities. So for today's agenda, we have the MLITSD Occupational Hygiene Campaigns 2025 to 2026. Then we will go over the employer obligations under Regulation 833. Then Maddie will take us through what is an air exposure assessment, and we have some tips for you on how to prepare for the campaign and protect your workers. So let's get us started. What industry do you work in? Do you work in agriculture? Do you work in manufacturing, service, or any other industries? Please respond to our first poll so we can get to know you a little bit better. So I see some answers coming in already. We have many folks from the manufacturing. If you've responded others, perhaps you could put in the chat which industry that is. We also see some from service as well. Steel fabrication, of course. Education, that's another one that we see quite often. So welcome. R&D lighting control system, that's a unique one. So wonderful to see so many different sectors have joined us in today's Safety Connection. Thank you so much for sharing. So moving into the MLITSD occupational hygiene campaigns, there are currently 2 occupational hygiene campaigns underway. The first is the WSPS training based on the amended hazardous products regulation. And the Ontario Regulation 860 is the one that's related to this first campaign. The second campaign is the worker exposures to chemical agents in the workplace, Regulation 833. And this campaign highlighted in yellow is the focus of today's session. For both campaigns, the first phase is the education piece, starting at the beginning of the MLITSD fiscal year, which is April 1st, and it runs all year long until March 31st of this year. The enforcement phase also started in April 1st, as these campaigns are continued from the previous year. And it runs also until March 31st of this year as well. And now I have heard that 2026 to 2027 occupational hygiene campaign will be on noise and enforcing the noise regulation, which is Regulation 381, in workplaces where workers are exposed to noise, and there will be more information to follow, so please stay tuned. So the rationale for these worker exposures to chemical agents in the workplace campaign is that, as I mentioned earlier, occupational diseases are the leading cause of worker deaths. And every year, there are approximately 4 times more death from occupational disease than traumatic fatalities. So exposure to hazardous chemicals in the workplace may result in the workers developing an occupational illness. So identifying, assessing, and controlling these exposures will help to lower the risk of workers developing any occupational diseases. So focus of the campaign will be that the MLITSD hygienists will conduct proactive inspections to ensure compliance with Regulation 833, control of exposure to biological or chemical agents in all workplaces in Ontario where this regulation applies. And their goal through this campaign is to ensure that workers are not exposed to hazardous substances exceeding the occupational exposure limits. The inspections will involve assessing worker exposures to hazardous chemical agents by reviewing work processes, so what type of work is performed at your workplace, observing work practices, so how these work are carried, evaluating any current controls that you may have, and reviewing exposure data if you have any. In some cases, air sampling for hazardous chemical agents may be required to assess exposures and ensure that the workers are adequately protected. If you haven't done air monitoring previously, it is hard to determine if workers are overexposed to chemicals. So conducting the assessment will give you quantitative data and allow that comparison to the exposure limits. Now I will provide a highlight of the employer obligations under Regulation 833, which applies to the second MLITSD campaign. So this information is taken right from the ministry's website. As per Regulation 833, employers have a duty to take all necessary measures and procedures to ensure that the worker's airborne exposure to a hazardous substance does not exceed the occupational exposure limit. For some substances, they must ensure it is reduced to the lowest practical level. And employers can do this using the engineering controls. So this may include your local exhaust ventilation, administrative controls, such as your written policies, programs, training, as well as work practices. And under certain conditions, the employer's duty to limit airborne exposures may include providing workers with personal protective equipment, such as respirators. So in the Regulation 833, some of the highlights include the definitions, occupational exposure limits, or also known as OELs, hierarchy of controls, personal protective equipment, respiratory protection requirements, and how to perform airborne measurements and calculation of exposure. So for the full list of occupational exposure limits for chemical agents regulated in Ontario, which I believe, sorry, there's the comment on anyone else to only still see the first slide. Is that happening to everyone else as well? Oh, okay, so I think we're good. Okay, perfect. Thank you for clarifying. So apologies. So going back to the slides. So for a full list of the occupational exposure limits, you can go to the website that's on the MLITSD website that's shown at the bottom of this slide, or you can do an internet search for current occupational exposure limits for Ontario workplaces under Regulation 833. So when you do a search online, this is a snip of what you will see. So you can refer to this slide or this table to find any applicable occupational exposure limits for your chemical of interest. Here is a snip of section of the table. You can see the headings across the top here. So the chemical agent and its name, its corresponding CAS number for ease of searching, along with their respective exposure limit to the right. So here we have time-weighted average limit, short-term exposure limit, as well as the ceiling limit. And in the following slides, I will go over what these different exposure limits mean. As well, there's a column for notations. So for example, this specific chemical agent has a skin notation. And this means that you need to pay attention to workers' skin exposure. So in Regulation A33, you will find occupational exposure limits, or OELs, for different limits that apply to different lengths of time. So here first we have time-weighted average limit, or TWA. This refers to time-weighted average airborne concentration of a biological or chemical agent to which a worker may be exposed in a workday or work week. STEL stands for short-term exposure limit. So this is the maximum airborne concentration of a biological or chemical agent to which a worker may be exposed in any 15-minute period, no more than 4 times during an 8-hour work shift, and with at least 1 hour between exposures. Then we have what's called ceiling limit. This is the maximum airborne concentration of a biological or chemical agent to which a worker may be exposed at any time. So under Section 4 of the employer duties, employers must limit the exposure of workers to a hazardous biological or chemical agent in accordance with the following rules. Rule number 1, if the agent is listed in the Ontario table, exposure shall not exceed the TWA, STEL, or C set out in the Ontario table. And rule number 2 is that if the agent is not listed in the Ontario table, but is listed in the ACGIH table, then exposure shall not exceed the TWA, STEL, or C set out in the ACGIH table. ACGIH stands for American Conference of Governmental Industrial Hygienists, and Maddie will talk briefly more about this later in the presentation. And I do just want to mention that when we do an exposure assessment, if the shift length is longer than your typical 8-hour shift, then the occupational exposure limits, the TWA, will be adjusted to reflect the longer exposure time to the chemical. If the table that applies under paragraph 1 or 2, so that's a previous slide, set out a TWA for an agent, but sets out neither a STEL nor a C for that agent, then exposure shall not exceed the following excursion limits. The excursion limit is 3 times a TWA for any period of 30 minutes and 5 times a TWA at any time. Now, here in the province of Ontario, there are 11 substances that are prescribed as designated substances under Ontario Regulation 490. And at the bottom of the slide, we have the list of the 11 designated substances. So some common ones you may see could be asbestos, isocyanates, lead, and silica. And it's important to note that this excursion limit does not apply to designated substances. So under employer duties, in terms of measuring airborne concentrations, the employer must ensure that procedures for monitoring, sampling, and determining airborne concentrations comply with a standard method for workplace air sampling and analysis, or another method recognized in industrial hygiene practice, and that these are performed by or under the direction of a person who is qualified because of knowledge, training, and experience in industrial hygiene. So it's best to have someone like myself or Maddie conduct these assessments to ensure that they are using the methods that are recognized in current industrial hygiene practice. And remember that it is on the employer to ensure that the person conducting the exposure assessment is a qualified person. Continuing with the employer duties, the employer must take all measures reasonably necessary in the circumstances to protect workers from exposure to a hazardous biological or chemical agent because of the storage, handling, processing, or use of such agent in the workplace. And the measures to be taken shall include substitution of the hazardous biological or chemical agent, engineering controls, administrative controls, including your work practices, hygiene facilities and practices, and if Section 7.2 applies, personal protective equipment. So let's look at what Section 7.2 says. In health and safety, I'm sure you're all aware that we never want to jump to personal protective equipment such as respirators as the first and the one and only control for worker protection. So let's look at what Section 7.2 says. An employer shall protect workers from exposure to a hazardous biological or chemical agent without requiring them to wear and use a respirator, unless subsection 2 applies or the employer complies with an applicable code of practice. Then what does subsection 2 say? Subsection 2 says, the employer shall provide and workers shall wear and use a respirator appropriate in the circumstances to protect the workers from exposure to the agent. A, if substitution of the agent is not reasonable or not practical. And B, if engineering controls required by this regulation are not in existence or not obtainable, are not reasonable or not practical to adopt, install, or provide because of the duration or frequency of the exposures, or because of nature of the process, operation, or work, are rendered ineffective because of a temporary breakdown of the controls, or are ineffective to prevent, control, or limit exposure during an emergency. So this is a list of summary of when it is acceptable and okay to use respirator alone for worker protection. But remember that you always want to consider the hierarchy of controls when you're putting in the layers of controls and worker protection. An employer who provides a worker with a respirator shall comply with the requirements set out in sections 9 to 13 of Regulation 833 and refers to the respiratory protection program and includes employer duties under regards to respirators, respirator requirements, use of respirator, tight-fitting respirators, and care and maintenance of respirator. So remember that anytime a worker is given a respirator by their employer, the workplace must have a written respiratory protection program, or RPP, and to include the elements that are listed here from section 9 to 13 of the regulation. We will not be going over the details on RPP during today's Safety Connection, but these details are covered in another Safety Connection titled Respiratory Protection in the Workplace that has been recorded, and you can view the pre-recorded Safety Connection on our website at WSPS.ca. We can also provide assistance in developing the program as well if you need, and we are here to help you. This table, titled Assigned Protection Factor for Respirators, is taken from Section 10 of the Regulation 833. And this table shows an assigned protection factor for each type of respirators. For example, an air purifying respirator or half-face respirator provides an assigned protection factor of 10, and the air purifying full-face respirator provides an assigned protection factor of 50, which is a higher protection factor of the two. So selecting the right type of respirator that is required to protect your workers and ensuring that their exposure is below the occupational exposure limit is based on the worker exposure assessment and its results. Continuing with the employer duties, if an agent in the ACGI table includes a reference simple asphyxiant or see Appendix F minimum oxygen content, you must protect workers from exposures to an atmospheric oxygen level that is less than 19.5% by volume. So you always need to ensure that there are sufficient amount of oxygen in the breathing air, as some chemicals can displace oxygen, and any related hazards such as fire and explosion. So of course, ensuring that safe handling of such chemicals to minimize hazards associated with those chemicals. Section 8 of the regulation. If a worker has been exposed to a hazardous biological or chemical agent, and A, the worker or the worker's physician has reason to believe that the worker's health has been affected by exposure to the agent, and the worker or the worker's physician has notified the employer in writing, or B, the employer has reason to believe that the worker's health is likely to be affected by the exposure, and the worker has notified the worker in writing. The worker, if he or she agrees, shall undergo medical examinations and clinical tests at the employer's expense to determine whether the worker has an occupational illness because of exposure to the agent, and whether the worker is fit with limitations, or unfit to continue working in exposure to the agent. So these are the three options that will be determined by the treating physician. And depending on the results, the employer will need to modify the work for the exposed worker to ensure that the worker is no longer exposed to that chemical. And the employer shall then provide the physician who examines the worker with a copy of the records, if any, of the exposure of the worker to the hazardous biological or chemical agent. So it is very important to keep the records if you have had any exposure assessments completed previously, as these may be needed for review by a physician. And that brings us to the end of this section, employer obligations under Regulation 833. Now we have a chat question, so please put in your answers in the chat. What potential chemical exposures may be present in your workplace? So what hazardous chemicals could you use at your workplace? Any examples you can think of, feel free to share that with us. Ammonia, absolutely. Cleaning products. Mercury, that's one of the designated substances in Ontario. Absolutely, lots of volatile organic compounds that I see. Carbon monoxide. Yes, mold, silica. So of course, there are lots of different agents that we work with. So thank you so much for sharing. And now I will turn it over to Maddie to discuss what an air exposure assessment is.
That's great. Thank you, Jae-young. So next, we're going to cover what an air exposure assessment is. So an occupational hygiene chemical exposure assessment is sometimes referred to as air sampling or an air exposure assessment. It's a systematic process used to evaluate and manage risks associated with exposure to chemical agents in the workplace, like maybe some of the ones you listed here. And there are key steps involved in an exposure assessment process. The first one is the identification of chemical hazards. So what are the hazards that workers are exposed to? Characterization of exposure. So gathering information to describe and evaluate the exposures present in the workplace. Then we have exposure monitoring, or measuring the levels of chemical agents in the workplace air, or it could be on surfaces, or even in biological samples from workers to determine the extent of exposure. Next, we have risk assessment. So comparing the measured exposure levels, typically to occupational exposure limits, to assess the risk to workers' health. Then we have control measures. So implementing engineering controls and administrative controls and personal protective equipment to reduce exposure to acceptable levels. And then we have documentation and follow-up. So keeping detailed records of the assessment process, the findings, and the control measures that you implemented. This whole process helps to ensure a safe working environment by identifying potential hazards and implementing measures to protect worker health. So next, we are going to cover exposure assessment strategy. So let's use our React feature, and please give me a thumbs up in the chat if you are familiar with the RACE approach used to address workplace hazards. Give me a thumbs up if you are familiar with the RACE approach. I see, yep, oh, now lots of thumbs coming up. That's awesome. So more than a few of you are familiar with the RACE approach. That's great. If you aren't familiar, don't worry. Yep, thumbs up in the chat. Perfect. I'll go over the RACE approach now. So the first step is recognize, which involves recognizing or identifying potential exposures in the workplace. The second step is to assess, which means evaluating the extent of exposure and the potential health impacts. The third step is control and involves implementing those control measures to reduce or eliminate exposure. And the last step is to evaluate, which means continuous monitoring and effectiveness of those controls. So the steps in the RACE approach are going to be highlighted throughout the next few slides as we go through this section on air exposure assessments. The step that we are in will be highlighted at the top right of the slide. I also want to highlight for you folks that guidance documents are a useful tool that can help to outline methods used to evaluate and control hazards. So one guidance document and resource that I use is the American Industrial Hygiene Associations, or AIHA's, a strategy for assessing and managing occupational exposures, which can be found on AIHA's website. Now, let's talk through the steps in assessing occupational exposures, starting with our first step of recognizing or identifying potential exposures. You can see here that we are in the recognize phase of the RACE approach. So before we can assess exposures, we need to identify chemical hazards in the workplace. This includes consulting with workplace parties, including supervisors, workers, your joint health and safety committee worker or health and safety representative, and even product suppliers. Sources of information can include conducting a facility walkthrough, reviewing your current chemical inventory, and reviewing product safety data sheets, or SDSs. You might also turn to other reliable sources, such as reliable journal articles, manufacturer information, and even reaching out to industry associations. So an example I can think of here is when supporting a workplace for an exposure monitoring assessment during a 3D printing process. I communicated or gathered information with the supervisor. They provided me with SDS sheets, as well as some information from the product supplier that helped me identify what I would like to sample for. And I also reviewed some reliable journal articles to help me identify what are some possible exposures that I could see. Next, we're going to review qualitative exposure assessments, and you will see that we are in both the recognize and the assess phase of the RACE approach. So give me a thumbs up again, folks, if you're familiar with the qualitative exposure assessment. Give me a thumbs up if you're familiar with conducting a qualitative exposure assessment. I see 1, 2, 3, 4, a few thumbs up coming through. That's great. For those that aren't, a qualitative exposure assessment identifies potential workplace hazards without relying on numerical data or measurements, and instead uses professional judgment. So we just talked about identifying workplace exposures, and the next step is to evaluate workplace conditions by further reviewing the tasks and processes. So these steps are part of conducting a qualitative exposure assessment. So when reviewing tasks, they are broken down to help evaluate the products and how they're being used. So for example, a painting process should be broken down into the various steps. Maybe there's surface preparation tasks, mixing tasks, and then finally your spray painting tasks. And that breakdown will help you identify that primer products are being used, likely base coat, as well as top coat products. Overall, for a walkthrough or process flow, we're looking at what products are used, how are products being stored, handled, and disposed, how much chemical is used, how often is the chemical used, the likelihood and frequency of exposure, as well as looking at who is exposed. I also want to highlight that risk assessment tools are available to support hygienists as well as other EHS professionals. So one tool that I'm aware of and use is Toronto Metropolitan University's, or TMU's, Chemical Hazard Assessment and Prioritization, or CHAP tools. These are available from TMU's website, and they even have some resources and guides that help you use the tool. There's also WSPS's Small Business Hazard Assessment tool that follows the RACE approach. So conducting a qualitative exposure assessment is the first step in conducting an exposure assessment, as it identifies potential exposures, helps prioritize exposures based on risk, which can be used to communicate risk to workers and management, as well as select chemical contaminants of concern or agents for sampling. The qualitative exposure assessment process also helps to identify similar exposure groups, or SEGs. So grouping workers who have similar exposures or hazards helps in assessing and managing health risks more efficiently. So workers may be grouped based on shared characteristics such as work location and performing similar tasks. If an MLITSD inspector visits your workplace, they will likely meet with workplace parties, they will review product SDS sheets, conduct a walkthrough, similar to what is done during a qualitative exposure assessment. Okay, so now that you have a better idea of how to prioritize exposures and select chemicals for sampling, we are going to review quantitative exposure assessments. Before we get there, I'm interested to know, has your organization conducted an occupational hygiene air exposure assessment for certain chemicals in your workplace? So put your answer in the poll here. Yes, you have conducted an air assessment. No, you know that you guys haven't, or maybe you're not sure. So just select the answer. Oh, I see lots of yeses coming through. That's great. So lots of folks, 29 folks, 30 folks have a few no's. So you might be thinking, based on what you learned today, is that something that I need to be doing? And a few not sure. So maybe this will help you evaluate whether or not you need to be conducting an air assessment. Okay, I'll leave it there, folks, and we'll keep moving on to quantitative exposure assessments. So you can see that we are now in the assess phase of the RACE approach. Quantitative exposure assessments measure or quantify chemical exposures. This usually involves collecting samples for comparison to occupational exposure limits. As Jay Young highlighted for us, OREG 833 provides the limits for chemical substance and biological agents in Ontario, and OREG 490 lists the 11 designated substances in Ontario, which includes arsenic, benzene, isocyanates, lead, crystalline silica. That's 5. I know she showed us the 11. Maybe we can get to the 11 in the chat. If anybody knows the other ones, feel free to throw them in. So ACGH TLVs are sometimes more conservative than regulatory limits. So the American Conference of Governmental Industrial Hygienists produces a new TLV book each year that may have OELs that are more conservative than the regulatory limits. So crystalline silica and benzene are 2 examples that I'm aware of. So although it's not a regulatory requirement, you might consider sampling for comparison to these more conservative TLVs. Okay, and it's possible that Ontario could adopt these TLVs in the future. And this green book here, the 2026 TLVs and BEIs, that is what the ACGH TLV book will look like this year. And thank you. Yes, I saw someone snip the substances in the chat. There are also other sources of OELs, including AHA Occupational Alliance for Risk Science, ORS, Workplace Environmental Exposure Levels, okay, and NIOSH recommended exposure limits. You might consider using these if there isn't a regulatory limit or an ACGH TLV for the chemical that you want to sample for. So before we can start air sampling, we need to answer these questions and develop an exposure monitoring strategy. So this is something I do regularly when workplaces reach out to WSPS for assistance with an air assessment. As we go through these sections, you'll start to understand why it's a regulatory requirement that exposure assessments are performed by or under the direction of a person who is qualified because of knowledge, training, and experience in industrial hygiene practice. And we will cover these slides and these questions in the coming slides, starting with what to sample. So our qualitative exposure assessment, including that review of safety data sheets, helps us to determine what to sample. So consider this example here. We're looking at section 3 of a safety data sheet for a welding wire being used to manufacture steel parts. We see that iron is the main constituent, followed by manganese, and then carbon and copper. This type of information helps us determine what to sample. This composition information helps us build our strategy, but there are other factors to consider as well, such as the type of welding, the type of steel being welded, and even the gases being used. So determining what to sample is an important part of an air assessment and should be done by a qualified person. Once we have determined what to sample, we can determine how to sample. And as Jae Young mentioned, there are standard methods for workplace air sampling. So these are standard methods for air sampling that have been validated. NIOSH, OSHA, and IRSST are examples. For example, NIOSH method 7303 could be used to sample and analyze for manganese. Methods will provide both sampling and analysis information. So for example, a standardized method will outline the appropriate sample media to use, the appropriate flow rate to sample at, how much sample volume to collect, collecting field blanks, as well as how to store and ship the media or samples. Laboratories have sampling guides available that help us to select a standardized method. So for example, Casson Testing Labs offers analysis for a variety of agents. If I was working on a sampling strategy and wanted to see the methods available for a certain compound, let's say it's for manganese, I would search their laboratory guide. Most labs that conduct analysis for air samples have a sampling guide. I would just also ensure that the laboratory is accredited for the analysis. And there are a variety of ways to sample depending on the contaminant type, including active sampling, passive sampling, and the use of direct reading instruments. And we'll look at these a bit more. So let's start by looking at active sampling. Active sampling uses a pump and tube to draw air through sampling media. Sampling media include cassettes, such as shown here, that might be used to sample for aerosols or particulates. Adsorbent tubes are often used to sample for gases or vapors. And sampling media can also include size-selective devices, such as cyclones or inhalable samplers, such as the one shown here. So these devices sample for a specific size fraction of dust. So some occupational exposure limits are for a specific size fraction. Crystalline silica as quartz, for example, has a respirable size fraction exposure limit. This means that a size-selective device would be used for sampling. And there are many chemicals that have size-selective OELs. And lastly, laboratory analysis is generally required when active sampling. Next, we have passive badge sampling, also known as diffusive sampling. It's another method used to monitor airborne concentrations of gases and vapors without the need for a pump. So the badges operate on the principle of diffusion. So chemicals diffuse from an area of higher concentration in the air to an area of lower concentration in the badge. And each chemical diffuses at a fixed rate depending on its properties. Badges are convenient to use and can be used to monitor a wide range of chemicals, such as styrene, benzene, and formaldehyde. And different badge types are available for sampling different chemicals. And similarly, after sampling, the badges are typically sent to a laboratory for analysis. Using direct reading instruments is a method for real-time monitoring of the work environment. They can be used to detect and measure the presence of substance in the air, including gases, vapors, aerosols, and particulates. There are many types of DRIs available for sampling different substances. The various direct reading instruments use different physical and chemical properties, or principles, to monitor contaminants in real time. So it's important to be knowledgeable in a direct reading instrument's principle of operation when you're using it. So for example, I often use a direct reading instrument with an electrochemical sensor when sampling for carbon monoxide. So the sensor uses a chemical reaction to produce an electrical signal that is proportional to the concentration of carbon monoxide in the environment. It's important to understand, though, the potential for interference from other chemicals in the air when you're using direct reading instruments. So some sensors may respond to gases other than the target gas, leading to a false reading. There are advantages and limitations to each sampling method we covered. This is, again, one reason why it's important that air sampling is conducted or performed under the direction of someone who is qualified because of knowledge, training, and experience in industrial hygiene practice. So now that we have covered what to sample and how to sample, we can cover who to sample. When selecting workers to participate in exposure monitoring, we want to ensure that we are collecting accurate and representative data. So the approach should include collaborating with the Joint Health and Safety Committee and workers to understand any concerns and help identify exposures. General approaches for who to sample include identifying similar exposure groups and sampling workers within these groups, conducting worst case sampling for workers with the highest exposure potential. So this might be at the highest production level, for example. Then we have random sampling, randomly sampling workers with similar exposure risk. Exposures are variable day to day and even between workers. So random sampling helps to capture that variability in exposure. Reviewing exposure monitoring reports or records might help prioritize those with a higher risk. And then we have area samples. So personal samples are usually prioritized as they are a better representation of a worker's actual exposure. However, area samples can play a role and can be used to evaluate the effectiveness controls and help to identify sources of exposure. So when someone like myself is conducting an air exposure assessment for workers on site, in many cases, they may be wearing something like, and you might recognize this person, the fantastic Jay Young is wearing in this photo. So an air sampling pump is connected to media in the breathing zone. And sometimes the workers wear the air sampling train, the pump in media, for the majority of their workday. So we always try and make sure that the air sampling train is comfortable and works well with the worker and their process so they can perform their job while wearing the equipment. So there are several factors to consider when determining the number of samples to take during an occupational hygiene exposure assessment. First, make sure to collaborate with the Joint Health and Safety Committee. They may provide input on where to collect samples. Second, we want to ensure that samples we are collecting are from representative work groups. Creating those similar exposure groups or SEGs can help and may help reduce the number of samples needed. For example, fewer samples could be needed from SEGs with low exposure levels. And remember that there is variability in exposures, and we want to be confident we are capturing those higher exposures. NIOSH provides some guidance on the number of workers to sample to get statistical confidence in the assessment results. This might involve sampling 9 of 10 workers, which isn't always practical. Newer Bayesian statistical methods exist that incorporate prior knowledge about exposures and may result in needing fewer samples to get statistical confidence. If you're building off a previous exposure assessment, you may consider taking fewer samples for lower exposure groups if you're confident that their exposures are low and well characterized. You can then prioritize sampling for those higher exposure groups with more variability. And for a baseline exposure assessment, you are characterizing the initial levels of exposure. This could mean collecting more samples to assess that potential variability in exposures. So overall, the number of samples to collect can vary depending on your specific workplace factors. Next, let's look at how long to sample. And remember that we want sampling to be representative of exposure. So TWA sampling is usually conducted for at least 75% of the work shift. So for an 8-hour shift, that would be for at least 6 hours. An assumption is made here that exposure during the remaining 25% of that shift is the same as the whole sampling period. So you want to make sure that this assumption is true, or you may need to sample longer to capture certain tasks, maybe higher exposure tasks like clean out of equipment at the end of the day. Task-based sampling is conducted for the duration of the task only. An example might be a potentially higher exposure task, such as chemical dispensing. Short-term sampling is typically done for 15 minutes for comparison to that short-term exposure limit, or STEL. And ceiling sampling is instantaneous, possibly with a direct reading instrument, as this is the exposure limit that cannot be exceeded at any time. So once we have completed sampling, the next step is to compare results to applicable exposure limits. So here is an example of a table you might see in an occupational hygiene exposure assessment report. We have our sample number with some sample information and our air concentration result with the exposure limit along the bottom. In this case here, we can see that the exposure is 5% of the OEL. Keep in mind that exposure assessment results may also include the use of statistical analysis. So the AIHA guidance document that I showed you, a strategy for assessing and managing occupational exposures, outlines performing statistical analysis for results within a similar exposure group to determine the probability of exceeding exposure limits. In general, at WSPS, we don't include the use of stats in our reports, but this might be the direction that we're moving in. So that completes the assess portion of the RACE approach. Next, we're going to look at controls. So again, folks, and I'm expecting a lot of thumbs up here, give me a thumbs up if you have ever heard the term hierarchy of controls. Awesome. Yeah, I see tons of thumbs up coming through. That's awesome. Okay, I'll go through it for anyone that hasn't. The hierarchy of controls ranks control measures from most effective to least effective. So starting with most effective all the way to PPE as the least effective. So I do have a poll question for you here, folks, and I'm interested to see what chemical controls are present in your workplace. So, sorry, it's a chat question. So it's all right. Just put in the chat, folks, if you don't mind, what type of controls are present in your workplace. So this could be local exhaust ventilation, an administrative control, or worker rotations. Yeah, sorry, folks, I said it was a poll, but it's actually just pop in the chat for me if you don't mind, any control measures you've implemented at your workplace. So if you've implemented local exhaust ventilation, let me know. Thanks, Deborah. Yeah, exhaust. Maybe you've introduced training on a certain chemical or exhaust. I figure we would see exhaust as a trend. Maybe any exhaust, again, for exhaust, awesome. Scrubber, exhaust and training. Any worker rotations, personal protective equipment. It's probably a combination or a layering of controls. Fume hoods. Thanks, Jamie. Okay, folks, I'll leave it there, but you can see we can have a common thread here of lots of exhaust, supplied air, powered air purifying respirator. Perfect. So we'll think about these as we go through the control feature. So starting with elimination. So elimination involves removing the hazard from the workplace. This could mean no longer using a hazardous chemical or redesigning a work process. Often, elimination is most effective when incorporated into the design or development stage of a work process. Substitution involves replacing a hazardous material or process with a less hazardous one. Examples could include substituting the use of paint products that contain isocyanates or lead-based solder with ones that don't contain isocyanates or lead. Another example is the use of water-based paints instead of solvent-based paints. Perfect, and I see someone in the chat here that changed the chemical, so that could be an example. Engineering controls. Engineering controls involve modifying processes, equipment, or the work environment to reduce exposure. So engineering controls can include isolating the hazard through enclosures. So for example, I have seen robots welding, painting, and even gluing inside enclosures. Engineering controls can also include the use of local exhaust ventilation, which helps capture contaminants at the source or along the path before they reach the worker. Examples are extraction arms. Next, we have awareness and administrative controls, which involve ensuring workers are aware of hazards and changing the way work is performed to reduce those hazards. This can include implementing training on safe operating procedures, including hazard recognition, as well as rotating workers through different tasks to limit the time spent in one area. So for example, in larger automotive manufacturing facilities that I visited, I often see workers rotate tasks each quarter or every 2 hours, likely for ergonomics, but also to control exposures such as from welding fumes. So instead of having one worker perform rework welding at a station for 8 hours, they have 4 workers rotate across the task, each doing it for 2 hours. And PPE is the least effective level of control. It does not eliminate or reduce the hazards and only provides a barrier between the worker and the hazard. Common forms of PPE include hand, eye protection, respiratory protection, body protection, could be coveralls or aprons, as well as foot protection. Keep in mind that workers need to be trained on the proper use and maintenance of their PPE. And PPE should not be the only method of protection, and higher levels of protection should be used whenever possible. So we can see we are now in the evaluate stage. So after we have implemented controls, we need to evaluate the effectiveness of those controls. This includes exposure monitoring to determine if exposures are controlled. Continuous monitoring helps to continue to characterize exposures and ensure that controls remain effective. This includes conducting periodic exposure monitoring. Document the evaluation process, including monitoring results and the controls implemented. And lastly, look for improvements to control measures, such as changing procedures. I've seen even small procedure changes reduce exposures. And just keep in mind, folks, that the RACE approach is a cycle of continuous evaluation. So finally, let's go over a simple scenario and build an exposure assessment strategy. So we have a structural steel component manufacturer with 4 welders who perform MIG welding, or metal inert gas welding, on mild steel for most of their 8-hour shift. The composition of the welding wire is in section 3 of the SDS, and as we saw before, consists mostly of iron with some manganese and lesser amounts of carbon and copper. Okay, and let's also assume here that the mild steel they're welding contains mostly iron. If the base metal were chromium containing stainless steel or aluminum coated, for example, this would affect what we choose to sample. Next, let's cover everything we just went over. Well, what to sample? So our wire and metal have a high percentage of iron, so we likely want to include sampling for iron oxide, knowing that welding produces metal oxides. The welding wire had a manganese composition of 1 to 2%. And manganese has a low exposure limit. And I have seen exposures above the OEL when sampling for manganese, so we definitely want to include manganese in our strategy. You could also include copper, but it has a low % content, so I'd be prioritizing manganese first. And you also want to consider any other exposures. Could be carbon monoxide or ozone generated during the welding process. And remember also that Ontario is still enforcing the 2017 ACGH TLVs. More conservative exposure limits have been published since 2018, including for manganese. So you might choose to compare to the more conservative OEL. How to sample? Well, I looked at our laboratory sampling guide and identified NOSH 7303 as the method to follow. This will tell me what pump flow rate to use and what media to use. Who to sample? Well, we have 4 workers, 4 welders, and since it's only the 4 welders, we could likely sample them all, but we at least want to make sure that we're sampling workers with the highest exposure potential. When to sample? We want to characterize exposures on a normal workday. So we might sample on a representative shift. If we want to determine the highest likely exposure, we could sample on a heavy workday or under worst case scenario conditions. And how long to sample? We can see that manganese has a time-weighted average exposure limit, so we would be sampling for at least 75% of the work shift. So this is a simple example highlighting some of what we covered today and hopefully helps you understand what to expect when having an exposure assessment completed for your facility. Remember that occupational hygiene exposure assessments must be completed by or under the direction of someone who is qualified because of knowledge, training, and experience. So I just want to cover a little bit more on what to expect on assessment day. First, if you have a joint health and safety committee representative or a health and safety rep, we will ask for a worker rep to be present. We introduce ourselves. We go over what we're sampling for and why. We will show the sampling trains. We'll also ask for any JHSC input on where we should be sampling. Sometimes with their input, we move a sample to a specific location that they like. Then we observe workers and their work tasks and make notes. If we're allowed to take photos, we might do that. We also review controls such as any local exhaust ventilation being used, the type of PPE being used, and we take notes on the types of PPE to confirm that they're appropriate for the work being completed. We also want to check the pumps and the workers each hour, at least each hour, maybe between 1 and 2 hours, to ensure the pumps are working and that the media has stayed in the appropriate place. So pumps can fail, media can fall off, and we just want to make sure that we're troubleshooting quickly to maximize that sampling time. And we also want to capture a representative portion of the shift. So we might not sample for the whole shift, but we'll sample for as much as possible and for that minimum of 75%. So thank you, folks. I'm now going to pass it to Jae Young to share a few tips with us.
Thank you, Maddie. So let's get started on some tips on how to prepare and protect your workers. So first, review your safety data sheets. Within the SDS, section 3 and 8 tell you information on the composition and information on the ingredients that make up that chemical or product. And specifically in section 8, it will tell you if there are any ingredients with an occupational exposure limit. Remember that regulation 833 table that we saw earlier in the presentation is a compliance that you as an employer in Ontario must be compliant to. However, as Maddie mentioned, there are exposure limits from other guidelines that may have lower limits, which you can choose to compare your results against as a best practice. Then you can gather any previous exposure monitoring reports that you have and look at when it was last completed, is it still relevant, and whether things may have changed. So for example, the chemicals that you used at your workplace may have changed, or the production level may have increased, then which will increase the worker exposure to chemical. Then determine if any remonitoring is necessary. And once you've determined that you would like to do remonitoring, then discuss the monitoring strategy with a qualified occupational hygienist, as well as your JHSC or health and safety representative. And remember to consider the points that Maddie had mentioned previously, so including who to sample, where to sample, the number of samples to be taken, and what to sample for. and also review the results and implement controls as necessary. So depending on the assessment results obtained from the laboratory, it could be a confirmation that your controls are effective and you're doing an excellent job of protecting your workers, or you may need to improve on your current controls. The inspectors may ask to see assessment results as a proof that your implemented controls are effective and workers are not being overexposed. Then this leads to our next poll question. Have you had a MLITSD inspector ask about chemical hazards during a visit? So have inspectors made their way to your workplaces? Yes, no, not sure. So I already see some answers coming in. We have about half yes, half no, some unsure as well. And remember, these campaigns will be going until the end of March, so March 31st of this year. So you may see inspectors coming into your workplaces until then. Thank you for sharing. And moving on to the next portion of what to expect during an inspection. So the MLITSD inspectors will enforce the Occupational Health and Safety Act and its relevant regulations based on the facts at the time of the inspection. And remember that an inspector has a right to enter and be granted access to all areas of the workplace. So remember that. And when an inspector arrives at your workplace, they will introduce themselves, explain the reason for the visit, which will be the proactive inspection, and ask to have a worker as well as the management representative with them during the duration of inspection. And the inspector may conduct an administrative review as well as a physical inspection of the workplace. So the administrative review may involve looking at your documents such as policies, procedures, safety data sheets, and any exposure assessment reports if you have done previously. Some physical inspections could include your current list of chemicals, its storage, as well as how they're being used, and potentially for any evidence of spills on the floor, for example. And these will be used all together to assess if there are any potential exposures and or overexposures to your workers. If an inspector finds a contravention, an order may be issued. The inspector will explain the contravention and may refer the workplace to a health and safety association for compliance assistance. So WSPS is one of the health and safety associations here in Ontario, and we are here to help when and or if you need any assistance with orders. It's important to note that inspectors will issue stop work orders where an immediate threat to worker health and safety has been observed. And at the end of the visit, a field visit report outlining the details of the visit, including the orders issued, will be provided to the employer. The order will quote the sections of the act or regulations of the contraventions, and it will be clear on what needs to be addressed by specific timeline. The order needs to be posted. Typically, I see them posted on a health and safety board, and it needs to be shared with the JHSC. And you can reach out to get any assistance that you need to address the orders as soon as possible. So we have connected with the provincial hygienist, Christina, to ask what some common orders they have seen at workplaces are. And these are some that she shared with us, and I'm happy to share them with you as well. So first, we have the Occupational Health and Safety Act. So under the Act, an employer must maintain equipment in good condition. So for example, if you have a propane forklift that is not maintained well and it's emitting too much carbon monoxide, there could be an order written for that. And also a requirement to do an air sampling for agents that have exposure limits in Ontario, and I believe there are over 700 agents, such as isocyanates, silica, solvents, and even dust. So looking at this photo on the right side, here we can see that this worker is obviously generating a lot of dust. There don't seem to be any local exhausts. Although the respirator is worn, the worker does have a beard. So this could be an instance where requirement to do air sampling to ensure that the worker is not overexposed to dust is required. And also to ensure that the respirators are worn correctly. The other MLITSD campaign that I mentioned at the beginning of this presentation is regarding WSPS Regulation 860. Some common orders related to WSPS include ensuring all containers entering the workplace are labeled with a supplier label, ensuring that workplace labels are applied when necessary. So sometimes chemicals are placed in an unlabeled bottle, such as water bottles, which may lead to unwanted results, such as accidental ingestion. So it is really important to ensure that chemicals are in proper containers and ensure to have proper labels. There's also the requirement to provide WSPS training, both generic as well as workplace specific, and ensuring that SDSs are available and accessible to all workers. So in terms of WSPS campaign, a good tip to see if you have SDS you receive from suppliers and whether the SDS has been updated in accordance with the new hazardous products regulation is Section 9, and particularly the addition of the R particle characteristics. And as you can see highlighted in red at the bottom of this list. So all sections listed here needs to be in the SDS, and even if the heading doesn't apply. So the supplier can put either not applicable or information not available next to the heading. So if the MLITSD inspector is reviewing your SDSs and can see that you have an updated SDS, the requirement to have updated WSPS training for workers for both generic as well as the workplace specific training applies to ensure that the workers have the most up-to-date information. Some common orders for Regulation 833 include conducting occupational air exposure assessments to ensure that workers are not overexposed. If the workers are overexposed, then of course additional controls are required. Then there's the respiratory protection program development. So if you're providing respirators to workers, then of course a written RPP is required as per the regulation. Then there's a respirator fit testing. So if the worker is required to wear tight fitting respirators, such as N95s, then they must be fit tested as well. And also a reminder that the workers must be clean shaven when wearing and fit testing for tight fitting respirators. Then we have Regulation 490, designated substances. So if you have any designated substances, which are the 11 agents that we saw earlier, you're then automatically required to perform what's called a designated substance assessment with a consultation with the JHSC. And based on this assessment, if it's determined that workers can be exposed to the agent and their health potentially could be affected, then you are required to develop a control program for that specific agent. A control program essentially is a written document with information such as how to safely handle a chemical, any medical surveillance. So this is an ongoing health examination with a physician, and any air exposure assessment requirements. We have an upcoming safety connection regarding designated substances in February. So if you're interested in learning more about this topic, please feel free to join us for that session. And last but not least, some orders regards to Regulation 851 industrial establishments. There is a requirement to train workers on hazardous agents to use the precautions and procedures to be followed in the handling, use, and storage, proper use and care of required personal protective equipment, so what types are appropriate, how to properly use and store the PPE, and remember, not all gloves are the same and provide the same protection against the chemicals. So having this written training document is important, as this is something that you can show the inspector on what you're doing to protect your workers. And in the proper use of emergency measures and procedures. So procedures on what are the required procedures when there is a small versus large spill? Do we have a spill kit? And do workers know where the kits are and how to use them properly? So again, it's important to have that written document for such emergency situations. And again, the inspector may wish to see this procedure, this written procedures, to determine that the employers are providing adequate information, awareness, and training to their workers for their protection. Now, when a worker is required to work with or is likely to be exposed to a hazardous biological or chemical agent that could cause injury to the eye or skin, then an employer shall provide as many of the following as are needed for adequate emergency treatment. So eye wash facilities, emergency showers, antidotes, flushing fluids or washes if the type of chemical requires antidotes. No food, drink, or tobacco shall be taken into, left, or consumed in any room, area, or place where any substance that's poisonous by ingestion is exposed. So as you can see in this photo to our bottom, this is a clear contravention of this regulation. If chemicals are poisonous by ingestion, which is information you can find on the SDS, consumption of food, drink, or tobacco around that chemical is prohibited to avoid any accidental ingestion and other means of exposure. Now for some resources to support the MLITSD occupational hygiene campaigns. So we have a toolkit that we developed, and within the toolkit, we have the FAQ document that we worked together with Christina, the provincial hygienist, regards to the campaigns. We also have how to read a women's safety data sheet, as well as some checklists for your compliance with the two regulations, 860 as well as 833, and regards to women's and chemical exposure. We provide a variety of women's training, including the generic training such as that 1-hour e-course. In addition, we can help you to develop workplace-specific women's training, which of course is very specific to your workplace and the chemicals that are handled. So looking at the SDSs that you have, which SOPs to be developed, and that training for your workers on how to handle the chemicals safely. And we can also assist with chemical program development, as we have building blocks for chemical management as well. For chemical exposure support, we offer occupational hygiene services. There are 11 occupational hygienists here at WSPS across Ontario, including myself and Maddie, that can come to your workplace and conduct air monitoring for you. And in addition, we can discuss any concerns or questions you may have about any hazardous materials that you have at your workplace. We also provide training on designated substances, respirator fit testing, and support program development such as the respiratory protection program through our building block. Previously recorded safety connections are available on our website, WSPS.ca, if you're interested in learning more about other topics. And you can also sign up for our newsletter and announcements on our website as well. I just want to share also that we have some additional upcoming safety connections within the next month or so regarding WMIS in auto service repair, designated substances, and so on. So if you'd like, please feel free to sign up and join us. And here's a list of references for our presentation today. And we can help. WSPS help through our free resources that's available on our website, complimentary consulting, providing training as well as certifications, and with WSIB Health and Safety Excellence Program. And now we have some time to answer any questions if you have them. Feel free to put them in the chat if you have any questions for us or anything that you heard during today's session. Is this presentation available to download? So this presentation won't be able to be downloaded, but it will be available to view on our website as a pre-recorded webinar. And I believe that will take about a few weeks for this to be available and on our website.
That's great, folks. Yeah, thanks for hanging in with us today. I hope you enjoyed the presentation. I saw some thumbs up and hearts coming through the React feature, so we really appreciate that. If you have any questions, feel free. We'll stay on till a few more minutes. Oh, you said that someone can come for free to check for chemical exposures. I would say on that, reach out to WSPS and we can assess that. There are some programs that we offer assessments, but reach out to WSPS. Even if you email J Young Lee or I, we can put you in touch with the correct people, no problem.
And our contact information is on the slide currently, and I believe it will also be included in the follow-up email that'll be sent to you. So for any other questions or clarifications, feel free to reach out to us.
Yeah. Thanks, Deborah. Thanks, Jennifer. With the respiratory protection program, I wanted to confirm that health screening questionnaires are required. So yes, so there is a user health screening that's done before you do like fit testing, for example, to ensure that a worker is able to wear a respirator. So that's outlined in the CSA standard. And if you take a look at our recorded respiratory protection safety connection, we cover that a little bit. Sampling method depends on the type of substance we are working with. Yes, exactly. So sampling method that we use depends on the agent you're sampling for. So there's different sampling methods for metals, different sampling methods for vapors, different sampling methods for isocyanates. So yep, you got it. Kristen, for sampling, for simple asphyxiants, our oxygen monitoring systems a requirement, or is it based on volume? I'm not sure on that one, Kristen. Maybe we can take that offline and I can get an answer for you, but I'm not 100% on that one. Sorry. Jay Young, I don't know if you have any thoughts, but.
Yeah, I'm not sure whether it'll be a requirement per se, but as you need to ensure that oxygen level is no less than 19.5%, I'd say it'd be a best practice to have oxygen monitoring if you're suspecting any displacement of oxygen.
Perfect. Thank you, Jay Young. That's perfect.
For
what if the supplier has not updated their SDS per the new requirement and not have provided? Yes, I did see it was December 15th. The supplier definitely should have updated it. I would say have your most recent one on file. Jung, I don't know if you know anything further on that related to WMIS.
Right. So yes, you're right. December 15th was the deadline. If you haven't received the updated SDS, certainly reach out to the supplier and see where they are at with it. I'm not sure if there's anywhere that you could reach out, so we can get back to you on that with further information. But like Maddie said, having the most updated SDS, as much as you can. If there's none provided by the supplier, then just have that available for your own records.
Perfect. And is there any regulation in which a person has to be certified to do hygiene sampling, or experience would just be enough? So as we highlighted, it's a requirement to be qualified because of knowledge, training, and experience, and it's up to the employer to make sure that the person doing their hygiene sampling is qualified for those reasons. Being certified, being a certified industrial hygienist or registered occupational hygienist is an example that might show that you have knowledge, training, experience in the practice of industrial hygiene. Thanks, folks. I'll leave maybe another minute for any other questions, but we really appreciate all these questions. That's great. I know it's getting close to lunch here, so if I don't say anything else in the next minute, then we'll close it off. And please feel free to reach out to Jay Young or myself on any questions you want addressed a bit further. And can extraction arms handle any type of chemical if the current ventilation cannot reach a dip tank? You know, on that one, Anne, I would say work with a ventilation engineer or your ventilation supplier for those types of questions. Could be chemical compatibility questions with the materials used, depends on what's being exhausted, right? So.
Do you need certification to do air quality testing? So again, I think this goes back to having that qualified person and to ensure that they are qualified through their experience, training, and knowledge. And certification could be part of that training as well, but not a requirement.
Yep, that's very true. Okay, folks, I see most of us are hopping off for lunch. I think I'll close it off here. Thank you all for joining us, and take care.
Thank you, everyone.